Hello there, this is Baligma. Today we'll be tackling a very interesting geometry question. In this question, we're asked to compute the area of the shaded region, which is enclosed by a larger square, ABCD. The shaded region is also a square. Normally, we'll probably want to compute the side length of the square. However, for this specific question, there's actually an easier approach if we were to divide the larger area into smaller subregions. And in order to do that, we will draw a couple of support lines to help us better visualize the problem. Firstly, we'll name the bottom point M and extend a perpendicular line from M to the segment AD, and we'll name the endpoint Y. Then we'll also name this point N and extend a line from N all the way to segment CD and name this point Z. And as we can see in the middle, there's actually a rectangle, and we'll name the four vertices A prime, B prime, C prime, and D prime. And if we observe closely, that technically the shaded region is computed in four areas, with the middle region as the first area, second area being the triangle on top, third area being the triangle to the right, fourth area of the triangle in the bottom, and fifth area being the triangle to the left. So technically, the area is just equal to the sum of all of these five regions. So in order to do that, we'll just calculate each region separately. For the first region, area 1, it's actually very simple with the given information. We have 3 and 4 as the provided values, which are just simply the length and height. Therefore, the area of the middle region is just going to be 3 times 4, which gives us a value of 12. However, the tricky part is on the rest of the regions. As you can see, these 4 triangles have no obvious information being given. However, if we observe closely, we can see, let's take area 2 as an example. We can see triangle 2 is actually half of the rectangle that includes it. And the same strategy applies for all the rest of the triangles. We can see all of these triangles are actually half of all of the rectangles that includes it. Therefore, the sum of all of these triangles is actually going to be half of all of these rectangles that includes them. So now our question is actually simplified in calculating the sum of all of these 4 regions into the rectangles divided by 2. And how do we do that? Well, we see that there's a larger square, and we're given the information that the square has an area of 100. We can actually see that the sum of all the rectangles that includes the triangles we want divided by 2 is going to be the larger square subtracted by the middle region 1, and that is going to be 100 subtracted by the value we just calculated, which is 12, over divided by 2, which is going to be 88 divided by 2, and that gives us a value of 44. And lastly, what we can do is use 44 and add the region that we just subtracted, add region 1, which is also equal to 12, and that's going to give us 44 plus 12 equal to 56. And that is the answer. If you find the content of this channel to be interesting, please consider subscribing and give this video a like. And as always, this is Baligma, and I will always wish you the best.